Okay, so the last thing in the bag of tricks we're going to go over is being able to take this texture and this whole setup here and put a grime layer or something over the whole thing. So how do we do that? Well, the first thing we have to realize is the easiest way to do it or is using channels. But Unity recently changed some of the things they did about channels, so it's important you understand that part. First off, let me explain what channels are. Channels are the ability to unwrap an object several different ways. That way you can put a material on an object in several different ways. Meaning that it sits on, you can put 3 materials on the object and they all are on the same object but look differently, and then you can layer them together. So let's start with that, and we'll get back to what Unity did recently. So I have this object here that we've seen inside of the Max. And I'm going to go ahead and put a UV wrap on it and open up the editor. And right now, this is in channel, you can see right here, channel 1. We're going to go over to channel 2. And when you push this button, it comes up with this weird dialog. What it's asking is if you want to move what you've already done or abandon what you've done and whatever's already in there, keep that. Import, I'm going to hold Alt.
Material and designate how our layers should be rendered. Lit shader. When we create a new material in the high definition pipeline, the material will default to use the lit shader. The lit shader is the best way to create realistic materials in the high definition render pipeline, which respond to lighting. Let's take a look at how we can design a material for use with the lit shader and explore some of its features. Let's create a new material and assign it to our floor tile here. The lit shader supports many different material types and allows us to define special properties in our materials, such as subsurface scattering, iridescence, or translucency. For now though, we'll explore what we can do with the standard material type. The lit shader uses a physically based shading model. The physically based shading model simulates interactions with light in the real world and responds in a consistent way under various lighting conditions. Artists working with the lit shader should follow real-world guidelines for the best-looking result. The standard material type uses a metallic and smoothness workflow to define how metallic a material is and calculates the interactions with light based on these parameters. Generally, we can achieve most types of real-world materials using these 2 input values. As we increase or decrease the metallic value, notice how our material reflects or absorbs more light. Similarly, as we increase or decrease the smoothness value, notice how our material becomes more or less glossy and reflective. We can adjust the normal map to add surface detail that contains different surface information packed into the red, green, blue, and alpha channels of an image. The red channel stores the metallic map, the green channel stores the ambient occlusion map, the blue channel stores the detail mask map, and the alpha channel stores a smoothness map. If we assign the floor mask to our material, we have a much more realistic mapping of both the metallic and smoothness values, and our material looks a lot more realistic. Finally, we can add a detail map to add micro details into the material. Much like our mask map, each channel of the detail map stores values our shader will use to render the micro details onto our material. Keep in mind that detail maps are always applied and may cause aliasing issues when viewed far too far away. At this point, you'll want to rely on a level of detail mesh with a more simple material. The red channel stores the grayscale as albedo. The green channel stores the green channel of the normal map. The blue channel stores the smoothness. And the alpha channel stores the red channel of the normal map. If we apply this metal detail map to our material, it now has more of a brushed and aged quality to it. By combining texture maps and settings in our lit shader materials like this, we can create a multitude of realistic-looking materials. There are many high-end games and applications that currently make use of photographed assets to provide highly detailed and incredibly realistic environments for users to explore. The high-definition render pipeline includes a layered lit shader that's perfect for texturing assets built with photogrammetry in mind. The layered lit shader allows us to stack up to 4 different lit shader materials together into one material. I've got a model of a rock here that I'd like to texture using some of our photogrammetry assets. We can create a new layered lit shader material by opening the Create menu and choosing Material. Then, in the drop-down, choose HDRP Layered Lit. The layer list shows the current materials assigned to this material. We can control the number of layers in this material using the layer count property in the surface input options. Let's set this to 3 layers, and then in the layer list, let's assign the materials we'd like to use. It's worth noting that each material is stacked based on their order in the list. So here, the main layer is the bottommost layer, and layer 2 is the topmost layer. Because the ground material is set as our topmost layer, it's currently textured over the entire rock. Instead, I'd like it to only appear on the bottom part of our mesh. So let's assign a layer mask to the material and designate how our layers should be rendered on our object. In the inspector, we can view all of the surface input options on each of our stacked materials and tweak them to get the best look for our object. We can also use the layering options to control how much our main layer influences the layers above. For instance, we can increase the base color influence on our stone layer to mix some of the albedo color from our main layer into the final output. The layered lit shader is a powerful feature of the high-definition render pipeline and allows you to
Hey, okay, so, for getting these materials straight, I know Nathaniel had mentioned putting, when we have the layered material all set up from his document, we've got this input for layer mask here. He mentioned putting the different masks into different channels, but I can't figure out how to get that to work properly. I mean, I understand, like, that I need to put them there, but as far as, like, putting them there, I have no idea how to do it. So I went about it a different way. Right now I just have, so I've got my brick material set up, but I don't have my layer mask set up right now. So I'm just going to apply this brick material. It's all jacked right now. So that is part way there, but obviously I want a layered material. Okay, so how I would go about this next is I would open up Photoshop, right? I've got a document here that's 2048 by 2048, and then um, I've got my exported masks from uh, from Substance Painter. So I've got my mask 1, mask 2, and mask 3 over here. I'm just going to pull those in. Okay. I'm going to make sure that they're all set up in an order correctly. Put them into my folder here, just to keep track of everyone. And then we'll rasterize them. Oh, that one's really shitty looking, but whatever. Okay. So instead of going in and fucking with the channels, we'll just do it through here, through the blending options. Alright, so we'll just turn off green and blue for this first one. The second one we turn off red and blue. And the third one we just turn off red and green. Okay, so that should be all of them. This is what our mask is going to look like now. And then we should just be able to export this. So file, quick export as PNG, whatever. I've got a folder here for them called my edited layer masks. This is going to be my brick material mask. Okay. Now we can import this under, I made a new folder here for it called my Photoshop mask section, just to keep stuff separate, just so I'm not overwriting anything. We'll import new asset, this brick mask. Now, it looks all jacked again, but that's cool. Okay, so we got our brick layered material, and we just pull this into the layer mask. Ta-da!
In this video, I'll share a few lighting and rendering techniques you can use to make your Unity projects look better. Lighting can be a complex topic. I'm going to try and keep this pretty high level for brevity's sake, but if I mention anything in this video that you're interested in learning more about, just reach out to me. I'm also going to show you a lot of techniques here, but I'm going to try and order them so the techniques that give you the biggest bang for your buck are earlier in the video, and some of the more subtle techniques are near the end. That way, if you only have time to watch part of the video, you're still getting some really useful techniques that you can use. At the end of the video, I'll try to provide a list of some good guidelines you can follow on any project to get better results. So feel free to jump ahead. Let's start by looking at our sample scene here. This is a scene I did not create, but I'm going to attempt to make it look better. One of the things I notice first is that the scene looks very flat and cartoon-like. This wall in particular jumps out to me. It's a blue color, but if we select the wall and look at the material that's applied, we can see that it's supposed to be pure white. This particular blue color, this sort of battleship gray, is a color I actually see in a